Hello, welcome everyone to today's webinar. Today we're going to be looking at the ModelOp Center architecture and how the different patterns we utilize apply to everything from deploying models within your organization or how you develop the models, how you report on the models, and all the different aspects and features that actually go into delivering that. So we're going to show you kind of the how behind the what we've often talked about. We spent a lot of time showing you different demonstrations of the abilities we have within our product. But today we're going to kind of pull the curtains back and actually look behind there and see the different architectural patterns that we use to integrate with your existing investments in enterprise services that you already have, coupled with the services that we provide. So that will be our focus today. And so initially, we're going to start out actually looking at the overall architecture of how our system is designed, because that really is critical to how we are able to deliver those integrations with your existing enterprise services that we talk about. First off, we are a microservices-based architecture. That does mean we are truly stateless. We have multiple different services providing different aspects of our product, and we're going to dive more into different details of those as we go along. We're going to be looking a lot today at our model manager microservice, as well as our model lifecycle service. Those two are kind of some of our central services that really provide a lot of our capabilities. But as we talk about some of the other integrations and stuff, we do have services that directly provide integration, like a Sagemaker service, and we'll be talking a little bit about that as well as add-ons like a document generation service to pull information into Microsoft Word documents, or Spark integration to actually integrate with Spark runtimes for execution environments. All of these microservices that we use are actually sit behind a Spring Boot instance that couples with Eureka for dynamic registration of services, as well as horizontal scalability of any given service. So it'll actually a load balance between multiple instances, so you can handle things like either a failover or a situation where perhaps you want to increase the capacity of the system as well on that. So additionally, there's things like the reporting service that provides real-time updates as to what's going on within our system. All of our all of our integrations with development environments, BI tools, etc., go through this Spring Cloud Gateway to access our RESTful services, as well as we will provide the integrations with Git, Jenkins, CI/CD, ticketing systems, etc. And we'll go more into those as we dive into each of the individual services and talk about that a bit more, as well as with a multiplicity of runtime environments for actually execution of models. So we have things such as our own ModelOp runtime, which we'll talk about a little bit further along, as well as other alternative runtimes such as Sagemaker for running Sagemaker's models, or PySpark, a Spark cluster, actually running that as well as things like Dataiku and other environments. So you'll see how these all interoperate together by composition. And that's what's important. You'll keep seeing throughout here is how we can actually compose not only our services together through model lifecycles, but also your existing enterprise investments, so that we can move information seamlessly between those systems that you already have, as well as our own services, and actually action on those. And what that's our process automation. We'll go into that more. But let's first specifically talk about some guiding principles we have behind our architectural approach. First of all, everything we do, we're using Docker native microservices architecture, so they're all fully REST compliant. So we can do that stateless composition between different services, providing the information in that stateless manner. When we're Docker native, we typically run under some kind of a containerized environment where it can be managed, such as Kubernetes or OpenShift or any of those varieties. We are not tied to any specific containerization environment, and we are not tied to any one provider. So it can be Azure, AWS, on-prem, private cloud, all of those kinds of solutions we have installed in the past. And one of our other things, when we go to actually install this, we actually run with the customer's network and typically are in on-prem or private cloud. One of the reasons we specifically chose this is we are dealing with sensitive data, PII data, that's associated with your models, et cetera. So we do not believe it's realistic to do this as a software as a service type pattern, because you need to export your terabytes of data to our system to then read in to do monitoring or other kinds of things like that. So for those reasons, we very specifically do typically an on-prem or customer private cloud installation. We provide Helm charts that make the installation fairly easy and upgrades easy as well. And that so they can basically go into any kind of an existing Docker Kubernetes infrastructure combination there. Again, we've talked about this up front already, but I do want to point out we are designed to integrate with your existing investments, as opposed to replacing them. We're not going to have you come to our solution to do ticketing, for example, for like bugs or work ticket items, et cetera. Instead, we choose to integrate with things like Jira, ServiceNow, Xamarin, and other custom solutions as well. We're not coming in to say, put all your model source code into our system. We integrate with things like Git, et cetera. Jenkins and CI/CD pipelines are included in those kinds of integrations because we know that you've already made investments there. We don't want to come in and replace them. So we very specifically want to work with your existing investments there. What we already talked about data a little bit, but further, by design, ModelOp Center does not store any of your data for your models, like training data, baseline, et cetera. Instead, we prefer to store references to those data, and we have quite a sophisticated methodology of actually being able to describe those as what we refer to as assets. Now, so an asset could exist as something like an external file in S3. It could be a SQL query into a data warehouse. It could be, HDFS file. It can be any kind of things. And we'll actually store the information about how to get to that file, any versioning information that that system can provide us, as well as any parameterizations that are required for a specific SQL query. This is done very purposefully because, again, we don't want PII data in our solution. Instead, the only time that that data needs to be accessed is if you're doing, for instance, something like a standardized test or a monitor to run on that, and only that localized runtime environment needs to access that, and would only export the scores back out to our system, not any of the data. So it's done in a way that we don't need to actually read your data in our system. We don't have to store it. You can keep your PII information secure, and also you don't double up your storage. We're not asking you to move your data out of your existing data lakes, data warehouses, S3 storage, or however you choose to actually store your data. And finally, very similar to that, we don't we very specifically don't have the concept of users maintained in our system. Instead, we leverage OAuth 2 to ensure that we integrate directly with your existing security infrastructure. Overall, this allows you to manage groups, et cetera, external to our system, yet we will inherit those through Java Web Tokens and other OAuth 2 mechanisms, such that we will be able to leverage that information, but you can manage your organization in one single place with one single sign-on, et cetera, on that, and not have to come to our system to duplicate that kind of methodologies. So this really helps us in the long run to, again, leverage your existing enterprise investments, and that's why we've taken that approach. So I want to dive into a couple services in specific here. Ones we're going to be talking a lot about because they store a lot of the information and a lot of the automation. The first one that stores a lot of their information we refer to as model managed service. It is kind of our central model inventory at its core. So it's going to store all the information about the models, including how it gets used, any jobs it gets executed, where it was deployed, specific versions of the model, information about the model itself, including the assets associated with the model, overall dashboard statistics of the usage of the model, and then its overall health, et cetera, on there. So there's going to be a large amount of information that we actually stored within our system to provide that. It actually interfaces with development environments to capture model information. We'll be talking about that in very specific detail because there's a few different models we follow on that, because we are not trying to be a model development environment. We are very specifically believe there's a multiplicity of tools out there. There always will be, depending on what you're trying to accomplish. If you're developing an ML model, you're going to probably want a very different tool set than if you're developing a traditional logistic regression, or perhaps even just a simple decision table. Those are all models to us. They all have very different environments in which they're developed. So we choose to integrate with those multiplicity of tools, and we'll capture information about those development environments in this inventory. And we're going to, as I said, we're going to dive into that one very specifically with several different examples on there. And also we will sync all of information with existing source code repositories such as Git. So, if you've already invested in source code things, we don't require any specific version of Git. It could be GitLab, could be GitHub, could just be your own hosted Git. Doesn't matter to us, but we will actually track and manage informations and capture commit IDs, et cetera, about that information. Additionally, on top of that, we have a very good job abstraction that information is also stored within the Model Manager service. Basically, it interfaces with runtimes and CI/CD platforms for capturing the information about the jobs that were run there. So, for instance, if you had a Spark job, we can represent that, or a transform job in Sagemaker, we'll talk about more as well. Or even to us, if a model is put through a Jenkins pipeline, there's a Jenkins job associated with that. And we want to capture that information and make sure you can see how those jobs were actually executed against your models. Now, the model lifecycle server, that actually is our automation framework that actually drives the processes and actually provides that kind of ability to do this composition between all of the different services that are out there that are both ours and ones that you already have invested in within your situation. So model life cycles, and we'll show you an example of one in the next slide on that kind of things, are the definitions that basically allow us to describe the flow, the decisions, et cetera, that move that. And this model lifecycle server stores and executes those. It will talk to external services to both send and receive information. So for instance, it can be talking to your Artifactory service, or talking to a Veracode instance, or it can be triggered by a Control M or a Quartz external task scheduler and that kind of thing to actually basically move these automations forward and et cetera. There's both kind of the concept of external triggers, where basically that will actually allow an external process to tell us to start and to do something, or it can be external tasks where they're long-running tasks that could be days. So for instance, creating a Jira ticket or a ServiceNow ticket and waiting for that ticket to enter a done or a rejected or one of those different kinds of states that you can actually specify, which could take weeks, months, years on that kind of thing. So we can actually manage that through these external tasks, as well as executing longer running CI/CD tool pipelines like a Veracode, Sonar Cube scans, et cetera, and those kinds of things, as well as model monitoring of actually doing analysis of models for things such as concept drift, data drift, et cetera. And we'll be looking at the details of how that's done more. And then you have all these different delegates that speak out to your existing services, things like Artifactory, New Relic, Dynatrace, Jenkins, et cetera, or even custom proprietary services that you actually already have, as long as they can speak a standard protocol like a REST, a SOAP, et cetera. And then you'll be able to stitch these together to actually move information from one place to the next. We do these through the model life cycles. This literally does move business process. It's written in industry standard BPMN 2.0, which is an XML notation, but there's graphical tools readily available, open source, to actually create and edit these, to actually design your overall automation process. It'll actually execute on various ModelOp services that we have. So you can, for instance, grab any information about a model. You can be triggered when a model has been modified. You can be triggered when a new job executes or a monitoring task completes. Anything that occurs within our platform, you can actually start or continue a process on based on the information that's provided there. It'll actually can push and pull information from these different integrated systems. So for instance, we can say take that a new model has been created, grab the source code assets from that model, send them to a Jenkins job that executes a Sonar Cube scan on the to check for any vulnerabilities, and then look and see the results of that and make decisions around a path based on which way we want to go. So we can actually make decisions. So for instance, in this exact diagram at the right, at this point in time, we can actually run some data quality analysis on the training data that was provided and make sure it looks like it passes a minimum criteria. And if it doesn't, we can say, hey, go back and we'll push that what actually the issues were to a JIRA ticket and create a JIRA ticket that the developer to receive and actually associate that back to the model. So all of that information is moving between all these different systems of, our model managed service, executing a monitor, running some tests on external runtime, capturing the results of that, and then pushing it into a JIRA to actually deal with it, or continuing it on and actually pushing it into a document review process and creating documents. So we can basically kind of push and pull this information in and out of all these disparate systems. This really gives us a much more powerful methodology than your traditional straight pipelines where, passing information becomes a lot more difficult than, the BPMN 2.0 standard provides for. It gives us great information to transform that information and move it from those systems to systems. And more importantly, it really does allow us this decisioning capability. So not only are we moving in a linear fashion, but we can branch and change course based on the different responses from these different services and what becomes available there. And ultimately, we're going to associate back to the model the exact activities, paths, and information that was actually moved through the entire process. And you'll be able to view that within your model and have a record of it. So it basically becomes a history of the governance of your models, proving what was done to those models, the rigor they were put under. And in the case of regulatory compliance, becomes an absolute wonderful tool to be able to show you did the proper due diligence that was necessary. And more importantly, even if you're not using it for governance and under a regulatory environment, you still have the ability to actually see where you are in the process as it moves along. So a developer can understand at what stage their model is in as it makes its way to production, because often we see it stall out at some point and get lost. And it just never makes it to production. We see this time and time again within customers. And by having this automation engine and these model lifecycle processes, we can make sure that it keeps moving forward. You can track where it is, and if there's any hangups, you can address those to allow the model to continue forward. Now, what we're going to start to look at, because a lot of times we end up getting confused with model development tools. We are very much not a model development tool. We view that as the experimentation phase, when you're really kind of playing with the model. And depending on how you're developing the model, what technologies you're using, that looks very different. So, you may be writing straight Python with very traditional libraries. You may be doing something like TensorFlow. You may be using more of an auto ML approach to actually do automated hyperparameter tuning on your neural networks. All of these are very different paths. So we realize that we have to have a way to integrate with a lot of different development environments and a lot of different choices, all of which are valid depending on what kind of an approach you're taking to your data science on there. So we're going to look at one first, which is what we refer to as a model factory, again, being those development environments without any form of an internal model catalog. So think things like Jupyter, RStudio, perhaps running locally or maybe in a minimally shared environment. They don't really have the great idea of a model catalog. You may see a bunch of files locally on disk, but that doesn't really get us the kind of information we need to have a robust inventory of the model. So that is a very common pattern, and we see that all the time. It can be as simple as just, yeah, I'm using straight Git and an editor on my on my local machine, and using VI even or something like that, and storing the items in Git, or using Jupyter notebooks or RStudio, either source code control managed or not. So, in these cases, we consider those local to the environment on that. For model factories such as Jupyter and RStudio, we actually provide plugins into those environments where they can directly communicate with our services through a GUI methodology. So you can register models, pull down models from our existing inventory to work on them there, and actually request, updates and syncs and upload additional assets and all of those different kinds of things. We also then can use that same plugin methodology to search and see what's actually out there and gather some basic information about the models that you own that are within your model inventory. Additionally, we have the idea of just syncing straight from a Git repository as well. We see this often. We have enterprises where they already have made source code control investments, where they have a large number of models already out there managed by Git with branching and versioning, etc. The ModelOp Center UI actually provides the ability to just say, start tracking this Git repository as this model, and we will actually do that and actually automatically clone that, map that into our definition of a model, start tracking the commit IDs, the specific repository information that's out there and that kind of thing, and allow you to actually freeze a model in what we refer to as a snapshot or a version of the model, where we will capture the exact Git commit IDs, et cetera, that are associated with that version, as well as the model frozen in time with the metadata, et cetera, that may have been edited there. So you'll have full capabilities of that kind of things. But this approach does require you to manage your Git your way, do your check-ins through either command line or visual tools or however you approach it. And that kind of stuff is not done through our system. You wouldn't go to our system to actually update that information. Instead, you'd update directly in Git, and our system will detect that and automatically keep all of that in sync for you. So this is a very generic approach that we see a lot of clients using that works quite well for a lot of kind of what we call vanilla development environments. But then there's actually a lot of solutions out there that we see now that actually have a concept of a model catalog. So basically, your model factory not only stores the kind of assets associated with the model, but also stores additional metadata. So perhaps about the names you've given it, tags you've assigned to it, any kind of hyperparameter information, et cetera, that can be a richer source of information than we get just from files on disk or a Git repo. For that, we would expect the model factory to provide some form of an API to communicate to it. And in fact, we've done this with several. So a couple examples of this are things like Dataiku and Amazon SageMaker. They both have these concepts within their own model factory model database. They have the source, the metadata, attachments, schema definitions, potentially even, and then we actually create a service, a microservice within our system that will actually basically communicate between the model factory's proprietary database and our database. And what we will do actually is just ask you to tell us to start tracking a model and provide us the necessary information for that. So for instance, with Amazon SageMaker, it'd be the ARN, to actually say, hey, this model is a potential candidate for production, so we would like to begin following it rather than just an experimentation. And all you will do is actually then tell us that to start tracking that, we will go out and transform all that information into the same format as what you see from a direct Git, with additional information that makes up the proprietary information that's associated with that particular model factory. So that way we have consistent fields. So for things like a version or a tag or specific information such as assets that are associated with like the source code, et cetera, you will have that consistent view no matter where it comes from. And that becomes very important as we actually start to want to execute those model life cycles and go through it. we can treat a SageMaker model the same as a Spark model, as the same as a Git-based model, as the same as a decision table, or even an Excel spreadsheet. This allows us to have that consistent governance view across all of these different technologies in that single pane of glass that becomes so important on that. In these cases, all development actually just occurs within that model factory. You don't have to come to us for anything. We're going to track those changes and see what you're doing there once you tell us to start doing that. You will do all development there, and basically it'll automatically be synced to our system. So the only times you'd need to come to our system to do anything is if you want to track the governance of it or provide additional information that perhaps the model factory cannot provide. So in specific, when we talk about SageMaker, I want to be clear how we actually do this. As said, for these kinds of environments, we have a very specific microservice that you actually install and bring up that actually you configure to talk to your different SageMaker instances. And then it will actually communicate to SageMaker directly, grabbing information from the model catalog as appropriate, and then syncing it over to the model manager service. It will also capture all information about any jobs that have been run. So you'll see like transform jobs and training jobs and stuff like that will be translated into the same job abstraction I talked about earlier in our model managed service. So you will right there in that same service see Jenkins jobs that were run on the model, SageMaker jobs that were run on the model, and in addition to monitoring jobs that were run on the model, all in one consistent view. So again, you can really see everything this model is actually going on. And to the Amazon SageMaker user, it will actually be fairly opaque in that they will just continue to execute their jobs through the SageMaker interface. And then all this information will actually be captured with our system and even potentially triggering model lifecycles if a new transform job is run or a new training job occurs or those kinds of things. We can actually trigger those automations on there. So all of the different UI and integrations we have with BI tools, et cetera, which we'll talk about more in detail, can trickle that information from the SageMaker database into our system and present consistent views across all of these different models. It really is quite complex. Just to give you an idea, this is one of our values, is that we've put a lot of thought into how we actually describe a model. So don't worry, you're not actually supposed to be able to read this. This just gives you the idea about the complexity of how we actually represent a model within our system. Now we make it easy to read in our UI, but I want to guarantee you we have robust information about what's actually in those models, what's associated with those models, what's going on with them within that experimentation platform, so that you have all that information available, recorded, and governed within our system. Now what I want to do is move on from talking about the development platforms, the experimentation phase, to actually runtimes being another concept, where how do we deal with different kinds of runtimes within our system, because models are going to run in different modes depending on what you need to do. For instance, we're going to talk about REST deployments. We're going to talk about batch deployments, as in like running a job, as well as touch upon Spark and SageMaker deployments as well, and that kind of thing. So we do provide our own runtime. We found that it's often when you're running generic Python code, etc., we've had difficulties finding a good runtime that can run with flexible endpoints. So things like you can have it list the same model without modifying the model code, can listen on Kafka, could switch over to a REST interface, could start writing out to a SQL database, could read from an S3 file. We want to be able to do all of that with the same model code. That becomes important when you're talking about governance, because if you modify the code to change the endpoints and have to do that, then what did you actually review in your governance process? You may have introduced new issues in the process of that. So our ModelOp runtime allows for that flexibility, as well as the ability to communicate to a large number of data sources out of the box, which becomes important in monitoring, which we'll talk about a little bit later. So what we're going to look at right now, though, is the idea of doing live scoring through something such as REST or Kafka. So basically the idea is that our model lifecycle would actually be responsible for doing that deployment. You don't deploy directly to the engine, because then you don't have any governance about what was actually run on those engines at the time it was making inferences, which we want. So typically what would happen is the model manager's model lifecycle server would be talking to the model inventory to gather information about what needs to actually be deployed. And then it would actually set up potentially endpoints on the different runtimes that are out there. Now, when it actually goes to deploy, it will actually create an immutable snapshot of that model and the deployment information that can never be changed. Model Manager will not allow you to modify those records after the creation, so that once it starts making inferences, we can guarantee we have all the information captured about the model, the life cycles it's been through, the assets it's using, etc., for the duration of the time it is deployed, as well as after. Once it is no longer deployed, we can capture that update that it was deployed between these times, and this was exactly what was deployed, and capturing that. So if you do have to go back and look at any model and actually understand what was making inferences at that point in time, you can actually do that. We already talked about those flexible endpoint definitions, so we can take the same model and actually deploy it into different use cases, providing different services, etc., based on that. So that will all be captured within those model lifecycle journeys. We talk on that. And then you can obviously, all of this information about what is going on with that particular runtime at the time is available through our system, where you can monitor them live, etc. But there's not always, you're not always doing live scoring. Another realistic approach that we see is a job API abstraction, where we're doing batches of data. So for instance, perhaps we're looking back over a day's worth of data to determine suspicious activity, or we're looking back on a weekly forecast, or any of these kinds of things. Very, very, very common to look at data in bulk like that. So we do provide, as I mentioned earlier, a job abstraction. So not only do we have what we already previously talked about there of a ModelOp engine runtime job, but we also have a SageMaker transformer training job, or a Spark job that actually runs, as well as a Dataiku job and others. So we have a consistent way to take model independent of type and actually create, through using the model life cycles, to actually execute jobs on these different platforms in a consistent pattern. Now, these could be triggered over time, and a scheduler. We already talked about we can integrate with external schedulers, as well as we have our own internal scheduler as well. And then, as they execute, more importantly, we will capture information about what was executed in those model life cycles and have recourse if something goes wrong. So not only do we just capture, oh, it went wrong, we can say, oh, the job failed, create a JIRA ticket, send some information to New Relic for real-time alerting, do whatever, and that will all actually be captured back into the model itself. So when a job that may be mission critical does fail, you can go back and get instant information about what was supposed to be run, where it was being run, the exact code that was being run at that time, and hopefully and track that the issue is actually resolved. So we can see who worked on the ticket to actually resolve that, and who approved it, or who said it wasn't really an issue, or even do things like generate an automatic exception report that gets associated back to the model that must be completed, describing the exception that occurred. We see that in some regulatory environments as well. And also, and this is what we're talking about when we're talking about basically incorporating information from jobs, even if they're in SageMaker or Spark, back into these model life cycles and moving in between the systems. So we really do have a lot of control of what we can do there. All of this information, once again, is visible within our system. You can see the jobs that have run, failed, etc. And you can do that on a model-centric view or a system-centric view as well. So we provide a lot of options there. Another form of model deployment, as we're talking about runtimes, we see this a lot of places. You already have done this with the CI/CD pipeline, and ModelOp recognizes that. We believe that's very common methodology, that there's a gateway between production systems and backend systems that has to be managed by things such as Jenkins jobs, etc. So for this kind of a pattern, again, we have actual model life cycles we provide out of the box that help help you in this kind of a process of how you actually deploy these. So rather than us deploying directly onto the runtime, either as in job form or as a dynamic responsive endpoint, like in the ModelOp runtime, instead we look at doing the deployment into an artifact repository such as JFrog or other industry standard artifact repositories. We feel this is a great pattern for dealing with existing CI/CD pipelines, and that what we will do is actually gather all the information, all that immutable information about the assets of the model, et cetera, actually do a deployment into an artifact repository by version ID, and we'll associate that deployment of the model back with the existing model. So you'll be able to go to the model and see that this version at this time was deployed to the artifact repository, and you can find it here. And then further, because we have our integrations with Jenkins, we would actually then trigger the Jenkins job to go do the deployment from a standard Jenkins deployment. So that could be into a Spark runtime, it could be to a ModelOp runtime, it could be into Sagemaker, it could be into your own proprietary systems. But once we actually trigger that job, that Jenkins job and its outcome will actually once again be associated with that deployed model object in our system. So you'll see that not only was it deployed into artifact repository, but then the CI/CD was triggered in Jenkins. Here's the Jenkins job. Here's the outcome of the Jenkins job, showing that the deployment either succeeded or failed. And we'll have all that information again from a model-centric view back in our model inventory. So you can see where even though we didn't physically do the deployment, we will have the information tying back from the logs in Jenkins as to exactly what happened there. So this is a great pattern to follow if you're already already have made these kinds of investments, or really want to have a protected and gated environment using traditional CI/CD tools, but still take advantage of the ModelOp Center information and governance. So now we've got the model actually out in production. It's deployed there. We're running away happily. Well, now we want to actually be able to monitor these models or different aspects of these models. So basically, we utilize the job abstraction for doing these monitoring, and then actually create what we refer to as model test results from that actually can be fed into our dashboards and other items we won't be discussing today, but you've seen on previous demonstrations. The idea here is that we want to do some black box analysis of data associated with a model. So for instance, a very common thing we see with machine learning is data drift if it's labeled data, where we want to actually kind of compare a baseline data set against more current data and actually do some analysis on these to indicate whether we should have some concern that the data is inherently different, or if we don't have labeled data, perhaps we're looking at concept drift, or we're doing bias detection on the predictions that are more recent predictions that are coming out. Any of these kinds of things. We have a huge collection of those that are out of the box, as well as you can actually provide your standard your own custom, monitors and tests as well. Once again, we use MLCs to drive this, because this will actually allow us to not only monitor, but do actionable monitoring. We use decision tables to actually be able to specify ranges and multiple parameters as to what acceptable outcomes from these monitors actually are, and associate those directly with either the model instance or the model usage, and actually then examine those. And if it fails, we can execute a series of different steps. If they succeed, obviously we would just mark it out as closed. But if it fails, we could, for instance, create a ticket, fill out an exception report, once again, raise an alert in New Relic, all kinds of different actions that we can do within your existing systems once again. And we'll have the ability to tell you exactly what failed, because we'll have the results from that DMN that tell us the exact parameters that failed, and we'll push it into those systems. So again, it's one-stop shopping for people who already have this a Jira or a ServiceNow. They're going to get the ticket with all the information from our system in there. And then if they need additional information, they can obviously come to our UI to actually determine like if they want to look at specific source code or who is working on it or those kinds of things. And then those we can look at the type of the model and determine where they should be executed, because we do have that consistent job abstraction. So if it's a Spark model, obviously it's probably dealing with large sets of data on your Spark cluster. We can create these monitoring jobs within the Spark cluster, but if it's a more generic like S3 data or something, perhaps we execute them within our environment or a SageMaker environment to do that. And again, we can do this in a consistent methodology. The results will appear consistently within the UI, and all of that information will be captured, and the actioning can be the same no matter which of the platforms that actually happened on. So once again, you'll have consistent results. And finally, what we want to talk about is, okay, now we've been running and gathering all this data out there within this system. We have reports, we have dashboards, we have out-of-the-box items, we have alerting, we can tie into your systems as well. But the reality is, when you're talking about a single pane of glass across your entire enterprise, you're likely going to want customized reports that really match kind of your business needs, and potentially also include some of your business values into those equations, or maybe from different systems and pulling them together and linking them. For that, we have actually out-of-the-box integration with BI tools. So we integrate with two specifically, being Tableau and Power BI. They both work a little bit differently, so I figure I'd describe to you how they actually work. Net result is the same, is that you can pull any of the information out of our system into these tools and create your own custom visualizations, custom reports, join them with your existing data from other sources, etc., to create these comprehensive shareable assets that you can move throughout your company to bring those together. So Tableau, they have what they call the web data connector. The web data connector is actually a bit of basically JavaScript that is actually pulled down into Tableau and executed to bring data into their system. This is their designed framework and how they do integrations like this. And what we do is we actually store our web data connector inside our Spring Cloud Gateway. This allows that to actually be downloaded directly through standard Tableau without installing any software, just by providing the URL of our gateway into their web data connector interface. What that will actually initiate is it'll actually initiate a download of that web data connector into your Tableau instance that is currently running on your machine, and then it will allow you full data connectivity to drag and drop our tables into different reports, and join them with any other tables, including our own, your own, etc., and create any of the kind of visualizations that Tableau works. So it's a very seamless way of bringing information in. Tableau, the only limitations they have is all that data needs to be in tabular format. So we do flatten our hierarchical data, which does provide some limitations in the Tableau environment around what information you can get at, because when we have lists, etc., there's only so much flattening we can do on that. So most information is available, but not all. With Power BI, they have a different methodology of actually interfacing with data sources. They require a plugin to be installed within their environment. We have created one, so we do have a ModelOp data plugin for Power BI that can be installed, and it will actually communicate directly through our Spring Cloud Gateway to our Model Managed service to allow you to query any of the information within Model Manager. Now, unlike Tableau, Power BI does support JSON nested data, and has a whole querying mechanism on top of that to allow you to transform it however you would like to actually deal with it in a more tabular format. We fully support that. So you're going to be able to basically bring in any information from our entire system and actually build their queries on top of that. Again, using those queries to actually join data with your existing data, our data, other data from other systems, etc., and then provide those visualizations and summaries within the Power BI environment. And again, be able to share those across the entire organization. This is really the whole goal of having this BI API support is, you're going to want things specific to you that makes sense for your business. And by providing this capability, which we have not seen in many other frameworks, you will be able to generate those reports without relying on us to make any modifications. You'll have full control of that and ability to do that. So really, we've gone through all this governance information throughout the entire process here of bringing these together. What we've done is, we started out with model development as we started talking about this overall architecture. We talked about those model life cycles and how they actually pull them together and can move information between the system. But more importantly, we're pulling all the information together. Then we talked about the runtimes where we can really do all those inferences and scorings. And then we can monitor those for quality. Are they still performing? Is the data still consistent with what it was trained on, et cetera, on that? And then finally, at the very end, we have our own dashboards right out of the box, right in our GUI that you can use to gather real-time information about the performance of these models and if there's things you should be looking at. But more importantly, you will be able to create your own reports using all of this information we gathered. Because if you can't display this information that we've gathered over time and just have it sitting somewhere, it's not nearly as much use for you. If you can actually roll it up into our dashboards and our reports that we provide, combined with your own custom reports for your business and how they're relevant to you. So I want to thank you all for joining me today in this, and I hope this helped provide you some insight about how we actually do all this. A lot of places make a lot of claims about, you can do all of this stuff. I hope I've really shown you the architecture behind how that happens to give you the confidence to understand we will be able to integrate with your systems. We will capture that information. We will pull it together, and all of this will allow you to be successful in all of your model governance situations. So thank you again for joining me today. Goodbye.